Chapter 8, Section 1 is about monomials and factoring. So we're kind of extending a little bit on what we were doing in the last chapter, Chapter 7, which spent a lot of time talking about all the things that we can do with different types of polynomials, where we're adding, subtracting, multiplying, dividing, some of those operations. Now we're going to kind of focus on undoing some of the multiplication that we saw happen last chapter. Now, in this first section, we're going to focus mainly on just monomials, which, if you remember from Chapter 7, a monomial is a single term. So it just has a number with maybe letters attached to it, but it's not going to have like plus or minus signs separating the terms out. Okay? So the first thing we want to talk about is something called factored form. So factored form is when you take this monomial and you express it as a product of prime numbers or variables that have exponents of 1. So when you're looking at these, you're going to be focusing on getting like your big numbers that you start with down to the prime factors. Now, if you don't remember, we're going to go over what prime numbers are. So remember, a prime number is anything that is only the product of the number and 1. Okay, so it doesn't have a whole bunch of numbers that can go into it. Some examples of prime numbers would be 2, 3, 5, 7, 11, 13, and so on. And there's lots and lots and lots of prime numbers that we could write out, but these are probably the ones that you're going to want to be the most familiar with, because you're taking these big numbers and you're trying to break them down into these smaller ones. So you're going to be looking for 2s and 3s and 5s to show up. And so just kind of a reminder that those numbers up there that I have listed out, the only factors that they have are 1 and the number that you see. So same goes for like 7. The only numbers that multiply to 7 would be 1 and 7. Same with like 11 and 13. So that's why like you don't see numbers like 9 and 12 and 15 on there, because those numbers have more than just the 2 factors. So we're going to eventually talk about getting these factors down and then being able to use them to find the GCF, the greatest common factor. And the greatest common factor is when you look at those factored forms and you look between multiple sets of them, and you try to figure out what they all have in common. So like what's being shared between the terms. Before we get too far into GCF though, let's do some practice with just our factor trees. We're going to start with this first one. I'm going to show you how this works. We've got 54 x squared y to the third. So I'm going to start by breaking my number 54 down. Now you could do this lots of different ways. There are several different sets of numbers that you can multiply together to get 54. So sometimes students think about 2 and 27. Other students might think of a different combination of numbers like 3 and 18. One that I think of right away is 9 and 6. But if you use a different combination of numbers, it's not a big deal. What matters is what happens at the end, like that you get all the same numbers written out across the line here. So 9 and 6 would be one way that we could break this apart. Now neither of those two numbers are prime, so I need to continue to break them down. So 9 is going to break down to 3 times 3. Now 3 is prime, so anytime I come across prime numbers, I circle them, just to make sure that I kind of know I've already taken care of those and I don't need to do anything more with them, so they're good the way that they are. Now 6 is also going to be able to be broken down, and we're going to break that one down to 2 and 3. Be consistent here with my colors, so 2 and 3, and then I'm going to circle those up as well. So now that I look at kind of all these branches in my factor tree here, they all lead to a number that's being circled, which means that all of these numbers here at the bottom are prime. So now what I'm going to do is write out my prime factorization, write out my factored form here. I'm going to start with my numbers, and we like to put them from smallest to biggest. So I'm going to put the 2 first, and then my 3's. And I've got 3 of them. Then I'm going to do my letters. So like up here we have x squared, and we have y to the third. If you remember from last chapter when we were kind of stretching out our monomials, x squared means that there's 2 x's. and the y to the third means that there's 3 y's. So this is what I want our final answers to look like here for our factored form. You'll start to see in a little bit when we get into the GCF why I want you to write it this way. And instead of like trying to condense it down, like sometimes I have students wonder if we can rewrite this as 3 to the third power. And you could, but for right now, we suggest that you wait to do that because we want you to be able to see certain things when we get into the GCF, which we'll get to on the next page here. What I want you to do right now, though, is on this first page, you should have 2 more practice problems. So there should be this first one here, and then this second one. I want you to go ahead and pause your video, take a couple of minutes to do those practice problems, and then keep watching to see what your answers should have been. So for this first one, 162, again, there's more than one way you could have done this. Probably the most common way that I see students do it is they do 2 and 81. Now 2 is prime, so I'm going to circle that one up. 81, though, can get broken down to 9 times 9, and those 9s can get broken down to 3 times 3. And then that gets us all of our prime numbers here. So then to write this one out, it should have been a 2. Don't forget about that 2 up there at the top. And then I have these 4 3s. And then my letters. I have 3 X's and a Y. Now for the second practice problem, I started this one by doing 4 times 7. 7 is prime, 4 is not. 4, we could break that down to 2 and 2. And so then to write this one out, it would be 2 times 2 times 7. And then for your letters, we have X, and then we have 3 Y's. All right, what we're going to do next now is extend on this. So we've done our factoring. We know what factored form looks like. We kind of understand the idea of what's going on there. Now we're going to apply this to what's called the greatest common factor. So instead of just looking at a single term, we're going to look at more than one. And we're going to try to find what's the biggest number, biggest amount of letters that we can put or pull from the terms that they give us. And that's called the greatest common factor, or you'll hear me say GCF for short. Now, the steps to doing this are very similar to what you were just doing. You're going to have to start by doing your factor trees for both of the terms that you have, or if you're given 3 terms or more. Then you look to see what they have in common. So what are the terms that you can see showing up in both of those factored forms? Then what you're going to do is multiply everything together to create your GCF. So, for example, down here on this one, we've got these 2 terms, 30x squared y, and we've got 56xy squared. So I start with the 30, and I do my factor tree. So I'm going to break this down to 3 times 10. Now 3 is prime. 10 needs to get broken down a little bit more to 2 times 5. So then down here, I write this out as 2 times 3 times 5, and then for my letters, I need 2 X's and I need a Y. Now, for the 56, we break this one down as well. 56 could be broken down to 7 times 8. 7 is prime. 8 is going to get broken down to 2 and 4. And then the 4 gets broken down to 2 times 2. So we have 3 2's, a 7, and then for letters on this one we have an X, and we have 2 Y's. So now that I've got my factored forms written out, I look to see what they have in common. And I like to circle them up. So I see that these 2's are the same. Now looking at my numbers, I don't see any other numbers that match. I do see some X's though, like 1 from each set, and I see a Y. So I just like to group them together, like what do I see showing up on both sets of numbers here. And that allows me to write out my GCF. So I take those pieces that I circle, so the 2, the x, and the y, and I multiply them together, and I get 2xy for my GCF. Now sometimes you'll have like multiple numbers that you can circle, and then you're going to want to multiply them together to simplify it. So after I write it out like a big multiplication problem like this, I just multiply what I can. And since this one was just a number and 2 different letters, I really couldn't change that much from what it looked like other than just taking out those multiplication signs. But sometimes you'll have numbers in front of it like 2 times 5 maybe, and then you would want to rewrite that as a 10. So there are 2 practice problems for this one as well, for this type of example. Here's this first one, and then there's another one down here. Just like before, I want you to go ahead and pause your video here, take a couple minutes, try to do both of these problems, and then come back and keep watching to see how they should have worked out. So for 6, I factor that to 2 times 3, and those are both prime. For 18, we factor that. I did 3 times 6, and then 6 factors to 2 and 3, and then I get all my prime numbers here. So for the 6x y to the third, I would have written that out as 2 times 3 times x times y times y times y. And then for your 18yz, I would have written that one out as 2 times 3 times 3 times y times z. And then I looked to see what they had in common. I saw a 2 and a 3 and a y. And so for my GCF, I want to multiply those pieces together. 2 times 3 times y, which simplifies to 6y. Now for the second practice problem, you might have noticed that the first one has 11, which is already prime. So you can't really factor that. So I would have just written this out as 11 times x times x times y. And for the second term, the 21xy, I would have factored that one. So coming up here, I would have factored that to 3 times 7. Both of those numbers are prime. So I said 3 times 7 times x times y. They don't share any numbers. They only share letters. They share one x and one y. So for my GCF, I just wrote x times y, which would just be xy. To finish up this section here, we're going to continue to work with GCF, but we're going to apply it now to a word problem. Asking that we've got this florist who has 20 roses and 30 tulips, and they want to know how many identical bouquets can the florist make. So we're going to start by what we were doing before. We're going to factor treat these. So I'm going to start with the 20. 20 is going to factor. You could do 2 times 10. 2 is prime. And 10 can factor down to 2 times 5. And again, those are prime. So coming down here, I'm going to write 2 times 2 times 5 for my 20. Now I'm going to do the same thing with my 30. 30, I could do 3 times 10. 3 is prime. And then 10 again factors to 2 and 5. 2 and 5 are also still prime. So now this one would say 2 times 3 times 5. So to find my GCF, that's when I look to see what's in common. I see a 2 and a 5. And so I multiply those together. 2 times 5, which would be 10. So that means I can do 10 identical bouquets. But they're also wanting us to take this a little bit further underneath here. And they're saying, you know, how many of each flower would be in the bouquets? So to find that, you take the amount of flowers, like the different types that you started with, and you divide by the GCF because that's the common number of bouquets that we're going to make. So we're making 10 bouquets. Now up above they said that we had 20 roses, so I would take 20 divided by 10, which would mean 2 roses are going to go in each bouquet. And then do the same thing with the tulips, and for the tulips we had 30 of those, so take 30 divided by 10, and so each bouquet is going to get 3 tulips. So 2 roses and 3 tulips. So I want you to go ahead and practice this now. So read through this practice problem here. Take a few minutes to work through it, and then come back and resume watching to see how this one should have worked out. So we've got these 2 rectangles. They're giving us 2 separate areas here. We got to start by factor treeing these 2 numbers. So for the 84, I started by doing 2 and 42. 2 is prime. For 42, I broke that down to 6 and 7. Now 7 is prime, but 6 we can go a little farther with and say 2 and 3. Okay, so for 84, I wrote that out as 2 times 2 times 3 times 7. Now for the 70, we're going to do 7 times 10. And for 10, we're going to do 2 and 5. So for 70, I write that out as 2 times 5 times 7. So to find my GCF, I look to see what they have in common, which they share a 2 and they share a 7. So your GCF would be 14. Okay? And then they go on to say, what are the dimensions of the rectangles? So each of them is going to have a 14. So what I do is that for my 84, I take that divided by 14, and so that would be a 14 by 6, and those would be inches, so 14 inches by 6 inches. And then for the 70, we take that one divided by 14, we get 14 inches by 5 inches. So those would be the dimensions of your rectangles.